Hey guys, how you doing? It's Coach Scott here with another little problem. So some of y'all were asking me about the cooling curve, all right? And it can be a little confusing. But again, how do we approach this problem? It's real simple, okay? It's real simple. What we've got to do is we've got to draw the graph and understand what's going on. So if we look right here, all right, let's see what I got. Let me go up here and get this little marker thingy. So how much heat energy is released? So it's telling me release. So we're going to talk about release. When 2 moles or 36 grams of water at 25 degrees C is frozen and then cooled to a temperature of minus 12 degrees C. So I've got a little bit of water, a fair amount of water, 36 grams. It's going to make a nice ice cube. All right. And it starts off at 25 degrees C. It freezes, means we're going to do a heat diffusion thing, and then cool to a temperature of minus 12 degrees C. So it asked me here to draw a graph anyway. So we're going to do that anyway. So we're going to draw our X and Y axes, excuse me. So let's see. Let's say our 25 degrees C is right there. So we're going to write 25 C just so we know what's going on. All right, so it's going to cool down. We know that. Then it's going to level off at the fusion point or freezing point. Then it's going to start to go down, which it does. That was a terrible draw. Let's go up here and see if we can erase that a little bit. Do a better job. Okay, let's draw this right here. Well, just erase the whole thing. So we're going to draw again. All right, let's change the color so we don't have that color. I don't want that color. So I'm at 25 degrees C. It goes down. Then it flattens out. Then it starts to go down again. So this, what temperature does water freeze at? 0 degrees C. Well, come on. There you go. Degrees C. And then it's going to be cooled down to a minus 12. Just put a little line right there. Okay, that's minus 12 degrees C. So here I've got a delta T of what? 25 degrees C. Well, actually it's minus 25. All right, because the final temperature there was 0 and it started at 25. Here I'm going to have a temperature of what? Our delta T. And I'm doing this just so I know what I'm dealing with over here. Minus delta T of minus 12 minus 0 minus 12 degrees. So I've got what? Let's see what I've got here. Let me go up here and get another marker. Let's see, let's go a little smaller and let's go right here with blue. I've got a phase change right here, which I can see, right? Okay, that's going from liquid water down to where it starts to freeze or fuse. So I've got a phase change right here. That's going to be QM cat. All right, and then I'm freezing the water right here. That's going to be using the molar heat of fusion. Molar heat of fusion, which is 6.02 kilojoules per joule per mole. And then I've got another QM cat where it starts to decrease temperature. So let's call this Q1. Let's call this Q2. Q2. And let's call this Q3. I know I'm going to be summing it, so over here I'm going to put Q1. That's what I'm going to calculate out. Then I'm going to find Q2. Q3. Okay, once I find all those, all I got to do is sum them up, add them together. So let's do the first QM cat. Let's go up here and do Q1. And that's going to be M cat mass C delta T. So our mass here is what? 36 grams. 36 grams. My handwriting's atrocious and this is not working right. There you go. Grams times, now let's see which specific heat. We got to use the one for water, which is 4.18 joules per gram per degree K, or per degree C, because we already got the delta T. And if you need to, you can go ahead and convert your Celsius degrees to Kelvin if that helps you out. Times minus 25 degrees C. I see that my grams and my K or C subtracted out. So now all I gotta do is hit my calculator. Got my trusty calculator. Right. See? Yep. So if I hit my calculator, I'm going to go 36 grams times 4.18 joules per gram per degree K times minus 25. I come up with a minus 3762 joules. Minus 3762 joules. Joules should be the right unit, so we're good to go there. Now let's look at Q2. Q2, I'm not changing temperature, so on Q2, let's go to a different color pen. All right, let's do green. Okay, so I've got Q2 equals molar heat of fusion is 6.02, and let's go ahead and convert that to joules. All right, so if I've got 6.002 kilojoules per mole, right? That's what that is. I believe mole's the same, so I could just do this. I know for every kilojoule there is 1,000 joules, because kilo means 1,000. So if I do that, I'm going to get 60220 joules. That way I don't have to worry about converting later. All right, so I got 6020 joules. Let's go back here. So that's the molar heat of fusion we're going to use. Ooh, I don't know what just happened there. Oh, no, I hit the button. Okay. Let's go up here and erase. Sorry about that. Gotta be careful with this pen that you don't hit the buttons, because then it does weird things. All right, so there we go. We're back again. So let's go back here and draw my green pen. So that's 6.022, excuse me, 6,020. That's terrible. All right, joules per mole. And I have how many moles? 2 moles. All right, and cancel those out. So 2 times 6020 should be 1240. And it is 12,040. That equals 12,040 joules. A lot of energy. Up here, we'll go ahead and put that in. Now notice that was positive. That can affect what's going on. Now let's look at Q3. Okay, let's go and change colors. We're ice now, so we're going to use that color. Let's go color. So over here at Q3, we're back to a QM cap problem because we had a temperature change. M C delta T. All right, so there we go. So Q3, our mass, 36 grams. Which C do we need to use? So we're no longer water, now we're ice. We're not liquid water, we're ice. So now we're going to use a different C. We're going to use this 2.005 joules, gram minus 1 to K minus 1. RC, it doesn't really matter, it's just a magnitude. And that was minus times minus 12 degrees. C, K, it really doesn't matter. We'll say K. So now I can cancel out the K. I can cancel out my G. Again, that's the times right there. So now I've got 36 times 2.05 times minus 12. I get minus 885. Well, 885.6. Then we'll go up here and put this up here. Minus 885.6 joules. Now all I got to do is add all this stuff up. So I'm going to add 12,040 joules plus minus 3762 joules. And I get a grand total of the Q. There it is. The Q total. Keep that one going. Q tote equal positive 7,392.4 joules. All right, so how many sig figs can I use? Let's see, they had 3 right there, 3 right there, 3 right there, 3 right there. So I can only use 3 sig figs. So what I'm going to do is convert that to kilojoules, which means I move my decimal over 3 places. I gotta go 3 digits, so that's going to be 7.39 kilojoules. I'm going to box that in, and then I'm going to write it down here because that looked terrible. 7.39 kilojoules. I've got 3 significant figures. I've solved the problem, and what did I do key there? I drew it out so I understood what was going on. I identified my different phases. I solved for each of the Q's of the different phases. Now I'm done. Not that hard, guys. You got this. So I'll see you guys tomorrow. Don't forget, we've got a lab safety test, and we might be able to move on to the atomic theory, and we'll have fun with that. I'll talk to you guys later. Have a good night.